Thank you, Kenya. So I'm going to get this set up. I just want to make sure that the documents that we're looking at are all saved and everything is live streaming. So we're doing a virtual session, which is a little bit different. I know everyone expected to be in California right now, enjoying the wonderful weather and out maybe doing some hiking, but we have to adapt to our surroundings sometimes, and this can happen. So I appreciate everyone that is here, making sure that their education is is taken seriously. This presentation is centered on the aspects of hurricane engineering and hurricane science over the years that has allowed not only the engineering community to understand better how to protect society, but also the home inspection community and the inspection community overall to know, what are the failure points of our buildings? Where are the areas that our buildings will generally have an issue? And the title of this slide, and there we go, we finally got this all running. So we're going to run the slideshow. The title of this presentation is Hurricanes Destroy, but only if we let them. So it's a little bit of a play on words in that, yes, they do destroy, and yes, there's something that are frankly terrifying and need to be adjusted for. But we have an option here. I say if only if we let them, because if we allow the engineering and the science to lead the way, we have the ability to resist these natural forces. So we're going to share screen on screen. So this presentation, as I said, is about Mother Nature. And it's really about how we forget the power of Mother Nature. This is the eye wall of Hurricane Michael, taken from just north of Panama City Beach on October 11th, 2018. The eye wall height of the hurricane was over 500 feet. This is a record-breaking storm. It was the third most intense Atlantic hurricane to make landfall in the U.S. in terms of pressure, and it was the strongest storm in terms of maximum sustained wind speed since Andrew in 1992. The topics that we'll cover today start with Hurricane Michael the morning after. These are photos taken from the search and rescue teams that were out there the day of and the morning after. They were dispatched by FEMA, as is typical for a hurricane situation. And the photos show you where the engineering failed or where the construction failed. And it's not necessarily intended to teach you construction or how to build new homes, but it's intended to talk about the buildings that collapsed. What age were they? What type of buildings were they? What were their weaknesses? And then what is the secret then to build strong buildings? What is the secret to make sure that doesn't happen to the buildings that we inspect or the buildings that we certify? Part of the secret is product certifications. Part of the secret is testing, making sure that the right documentation and the right products are used for the right demands on a certain project site. When those products are used properly, they must also then be installed properly. So we'll also talk about how trusses and joists need to be sat properly in their connector locations. We'll go a little bit over load path, which deals with how the structure grounds the load into the soil. Hurricane doors, hurricane windows, and hurricane shutters. These are components of the building that basically protect the building from imploding, more or less. When an engineer designs the building itself, if the windows, doors, hurricane shutters, if any of those, the roof-to-wall connections, if any of those fail, you have a link that is broken in the chain that could lead to a catastrophic failure. Then we'll go into a little bit of some field work. I'd like to go with a field review. There's a lot of questions that I get about, okay, I understand the need for hurricane straps and we've got the forms, but what do I do about this crack? Is this a severe crack or is it nothing to be worried about? We also have a case study for a settlement project where they retrofit a settlement, uh, what's the word, underpinning plan, so that the building, which was actively settling, would remain stable. A little bit about me. I'm Troy Bishop. I've been a general contractor since 2007. So I started out in the roofing business. I was in college at the time, and I couldn't believe, how hard it was being, strapping trusses down, nailing in plywood, trying to get metal to form around the plywood. So I studied engineering so that I didn't have to stay in as a roofer, and I was able to get that license in 2014. And since then, I've worked with local municipalities for disaster responses. I've done structural engineers emergency response, which was the Florida Keys in 2017. There's some photos in here from that mission. And just recently, after about a year and a half of training, I'm also a deployable member of the Miami-Dade Fire Department Urban Search and Rescue Team. So, all of this is just to say that this is valuable information that I like to share with the community so that the home inspectors know, what is it like? What are we looking at from a macro standpoint, from a zoomed out standpoint? How does it become law, and what is law? And then how do we apply that to 123 Main Street and the report that needs to be written, and if whether or not an engineer needs to be contacted. This is my favorite slide in the entire presentation. I captioned this: "Why is the code important?" And you may see nothing from this photo until you look closer, but if you look at the balcony, you see a few chairs and no railing. So I don't know how this would pass code or how anyone's allowing this, but when this house gets sold, hopefully a qualified home inspector will take a look. This will immediately be flagged, and the public is is safe again. But these are things that, believe it or not, without home inspectors or without the proper verification of the code, you end up with you basically end up with an unmanageable situation for society. Imagine if every balcony didn't have a railing like this. You would literally have a dangerous situation for a community because of the amount of injuries that you would likely have over time. So the code is important because in the course of a normal day, you probably see a million items that win the award for why is the code important. But at the same time, we also tend to forget the power of nature. This presentation is about awareness. It's about remembering why we enforce this building code, or why we enforce the rules of the state that you're in to do a home inspection properly. And this is why. This is Typhoon Fanny in Indonesia. Looks like the video may not be showing up properly, but the roof is lifting off based on the hurricane load. Here you have a group of school-age children that are attempting to keep the fire door shut, and the hurricane winds are able to blow them basically into the hallway. Yeah, window glazing that can't withstand the pressure of the hurricane forces that cave in. So it's easy on a sunny day. It's easy on a sunny day to forget that we're not designing for a sunny day. We're not inspecting for a sunny day. Even as I look out my home office today, that's raining outside, someone had to make sure that that rain was properly funneled to the proper drains in the roof, and those drains run out to the proper locations. The same thing with hurricanes, the same thing if in your area, if there's a fire protection code, seismic codes, they all apply. Any of these natural disasters can occur, and we have a fighting chance, and we're going to go over why. On October 11th, 2018, we were greeted with the third most intense Atlantic hurricane to make landfall in the US in terms of pressure. It was called Hurricane Michael. Panama City Beach, Mexico Beach were the prime targets of the storm. It was the strongest storm in terms of maximum sustained wind speed since Hurricane Andrew in 1992. Hurricane Andrew was one of the reasons why the South Florida Building Code was enacted and enforced, which became the high velocity hurricane zone building code in Florida. After that, Hurricane Erin and Hurricane Opal created the Florida building code. And then thereafter, those codes were combined. So here we have Hurricane Michael comes along, sets another record. It's the strongest storm on record in the Florida Panhandle at the time, ever. And it was the fourth strongest landfalling hurricane ever in the United States in terms of wind speed. Now, the crazy thing is in that time, those records have already been broken because every year, these hurricanes, they can get stronger and stronger. So Hurricane Michael makes landfall, Mexico City Beach, October 11th, 2018. And the next morning, its inhabitants wake up to see this. Imagine the same path that you take every morning to get coffee or go to work or go to your inspections, and you wake up and arrive on the street to see it blocked by emergency personnel, homes missing roofs, and streets eroded away. Many of these photos were courtesy of two members that were deployed after the storm, Mark Johnson and Captain George Duquesne. They were deployed in advance of the storm, and they were put to work. They are two structural engineers. They were assisting the urban search and rescue team in evaluating the damaged structures for safety, while the fire departments searched for bodies among the damage. This is a view of Mexico Beach looking east. In this view alone, almost 100 homes are missing. Now, when you talk about how wind affects structures, wind cannot navigate around sharp corners. So anytime wind needs to get up and over a roof, up and over rooftop equipment, anything that blocks the wind can create a flow condition where the wind separates, and you have these vortices or eddies that can be created that can then create high pressure regions. So you have these high suction zones that occur in the building. And those zones are very critical because if those high suction or localized vortices regions create enough pressure and enough force or load on the component, you can have a failure in the building. So it's a little bit like this. You have a primary structure, rooftop level. You have wind coming from the left side of the building. This creates a sort of left to right pressure or left to right load on the building. As that happens, the wind is also going over the building and it's lifting up. So there's a principle that requires basically that as you've got this wind moving over the top of the building, the faster it moves over the building, the more it's going to want to lift up on the building. So it's not only doing this to the windows, the doors, it's doing this to the roofing products, the shingles, the tile, the trusses, the roof strap, and eventually, as we'll talk about in this presentation, eventually down to the foundation. So these two arrows, these two loads are very important, and they have to make their way down to the ground for us to have a successful building design. And this is why hurricanes may destroy, but we can resist them with the proper building foundations. When you look at this image, this is an animated image of a 4-story building, fairly rectangular. They call it a non-irregular building in the codes. You can see in the front you have a positive pressure, in the back you have leeward pressure, and over the roof you have a negative pressure as the wind travels across the roof surface. You notice that there's a large localized vortice behind the building that's almost the size of the building itself, maybe twice as large as it, that creates a very large suction force as the wind rushes over the top of the building. And this can happen in 360 degrees of action. So these arrows can go in any direction depending on which direction the hurricane comes from and travels over the site. So you have these positive pressure in the front, negative pressure in the back. What happens is that in the positive pressure side, you end up with air, wind, water, and debris being forced into every opening you can imagine in the building. So the windows and door products need to have weather stripping. They need to be certified and tested for this amount of air coming in through them or not to come in through them, and certified and tested for the amount of water to come in through or not come in through. So this positive pressure is extremely important because it's how we get water and how we get debris into or onto the building components. The negative pressure, conversely, is where the building is being sucked away. Either you're going to have a window that might be pulled away, or you just may generally have a roof truss that's lifted up and pulled off of the building. So these are the components of how the hurricane forces work on a building. Now, if there are any questions as we go through, if you can just hold them until the end of a slide, and then Kenya can let me know, and we can answer anything as we go. So that's a little bit about how wind works and how, how we understand hurricanes to affect structures. So let's look at the buildings themselves. We've got a block of buildings here. There's probably about 40 buildings in this red square. On the lower left, you have building A, which we're going to look at later. And we have an Exxon gas station in the top right. Now, these buildings are residential townhomes. They are built as a slab on grade. That means that the wood framing of the homes, and maybe even if it were concrete framing, either way, is built directly on a concrete slab, which is poured onto the soil. So there's no deep foundation. There's nothing, elevated above the ground. This is basically a sitting duck. We don't yet have the year of when these were built, but let's say I'm assuming this is probably somewhere around 1960. Either way, we have a slab on grade, very close to the ocean. This is the aftermath. Building A is in the top right. It's got its own problems, but all of those homes are gone due to the forces of the hurricane, the storm surge, and the hurricane wind. Now, if we look at building A, get a little bit closer, you have four-story building. Now, it's an elevated building, so you have the building has the ability to resist floodwater in the effect that the floodwaters can run underneath it. How do we think this building did? Now, if you look at the railing on the first floor and look at the flat roof above, you have sort of that flat metal roof style or soffit covering, and the railing on the first floor. So we've got a complete detachment of the railing on the first floor, probably due to the tide or the storm surge coming in that high, 15-foot storm surge, combined with the roof uplift, pulling the roof off the top of the building, completely exposing the insides. This building is, while it's still standing, it's completely uninhabitable. It was designed for enough flood, or I should say it was designed for a flood, but not enough of a surge and not high enough. We've also got this set of buildings. It's a townhome built 1955. This is just down the road from building A. It's actually across the street. How do we think these did? These are right on the beach. Now they're elevated, so there's a little bit of space underneath, which is, helpful. This is the building after Hurricane Michael made a visit. What you'll notice here is one of the critical components. Let me see if I can draw here. This gable here, it's really important that we all understand the inherent weakness in a gable end condition. So if you ever see a building with a gable end condition, that alone is almost reason to make a slight comment to you, or to make a comment in the report, because a gable end condition, while it's part of the constructed residence, there's nothing we can really do about it, has a very high tendency, when there is a force applied to the top of it, has a very high tendency to want to roll over. That can be fixed with additional anchors in the plywood over the top. It can also be fixed with X bracing, perhaps in the attic. But it's a known issue. It's a known issue with buildings, at least in high wind areas. So much so that the code currently requires that any buildings that are sold that are $300,000 or more appraised value need to have a retrofit, an engineer sign off that all of these braces are intact and the straps are properly certified. So it's part of the code to understand that the gable ends and the strapping, if it's deficient, if the home is sold, may require additional engineering or additional work. So what happens is this truss here blows over, and we end up with, first the roof is pulled away, then the roof to wall connection fails. These are, looks like some floor trusses. Everything starts to go. Once the girders are gone, once the load path is destroyed, there's nothing left. So this is a pattern you might notice on a few of these as we go through them. This is the same property from the front. I mean, you can just see, you could almost rebuild this, you know, in your mind. You have the wall that used to be here. I mean, it's just completely destroyed this building, and it started here because you could see how much is removed, and then from there it just continued to pull off the rest of the building, and the remaining walls fared no better. So it's important to understand, you know, the engineering requirements behind this are that the building stays intact. It can get wet, it can move, but if we lose our load path, which is what's so important on a lot of those home inspections, is your roof to wall strapping. If you lose your load path, you really are going to lose a lot more than you think. This is a building that some of the buildings, when I've done emergency inspections or emergency responses, I'll look them up on Google Maps, and in front of me is a 2-story building, but on Google Maps it's a 3-story building. So this is another case of that happening. This is looks to be, it's got some dormers here. You can see these aren't real gable ends, but they're similar. They're dormers, and looks like there may be a gable end here as well on this building. So how do we think this building did? Now this one was built in 2012, so we're a little bit, you know, we may be a little bit better off. Doesn't look like they did too well. And the reason being that, again, the roof to wall connection is extremely important. If that connection is not salvaged or is compromised, then the trusses are lifted and the rest of the home is soon to follow. So even with a bit of a newer construction, in this case, there's so much damage. You know, you have just pulverized, the windows are completely pulverized here. There's so much, such a high pressure load that was forced onto this building that even if we do everything correct, sometimes, if we're not properly inspecting, I would bet that there's an issue, or there was an issue with the load path, the strapping, or the connections. The way that part of these were strapped just wasn't, it may have been per code, because up in the Panhandle, their code didn't require them to certify to this high of a hurricane, which is another debate. It's another topic on its own. But the maps only required about 30-mile-per-hour less than this hurricane topped out at. So if we don't design for the hurricane that we think is coming, we'll also have a failure. So it's important that we understand the strength of the hurricane. Let me erase the ink on here, so we can understand the force involved and how much we need to strap. There have been homes, this is the same home from another view, there have been homes where the roof was completely removed from the building and in a single piece across the street, because the roof had been built well, but it had not been attached to the rest of the building. So it's important that everything in this recipe is properly accounted for. It's like baking a set of chocolate chip cookies. If you don't have everything right, if you miss the eggs, you don't have chocolate chip cookies. So if the strap isn't there, or if the strap was nailed in because they were on a lunch break and you know, they didn't really feel like getting that strap in place, if you see that, you know, that's your responsibility to call it out, because this is what happens in the case where, and again, this was where a building that we actually tried. It was only about 8 years old at the time it was, or it looks like it was 6 years old at the time it was destroyed. So even when we put all of our heads together, sometimes we still have a failure. Here we have 1986. This was the same road, but a little bit further away. How do you think this one did? Now, if you look at this one, you have similar features that I would be concerned with. You have a gable end on both of them. So there's a tendency for what? There's a tendency for those walls switch color here. We'll go to something blue. There's a tendency as the wind pushes in here that these walls are going to want to do this, and then they want to fall over. Okay, so that's what we're worried about, is if the wind pressure is able to affect the front of that building and the wall falls in. We also have the same issue here. If the wind pressure is affecting the side of this building, the problem that I see with this building, even though it looks very nice, is that you have a very large sail here on the side that's just so conveniently set up to put a lot of pressure on this frame, and then at the same time you have the gable end condition. So you have wind that is simultaneously going to pressurize the side of the building and pull out the sliding glass door. So how do we think this one did? This one did not seem to do any better. So again, what's happening is you have wind coming in from whatever direction, but let's just say in this case you have wind coming in from the right side. It's going to apply a lateral force against the side of the building. Wow, this sketch is not well. And then it's also going to apply at the same time an uplift force, which explains why the third floor might be missing. And then lastly, and it's hard to see in this picture, but if you can try to imagine, if the roof is lifting up, also then the windows are trying to be sucked out because the wind is trying to go around the building, around the roof. So we have basically this building is being pushed on from all sides and from all angles. What I would guess is you have two things that may have happened here. Number one is you have an increase in positive pressure as you go up a building. So if this is the positive pressure line at the top of the third floor building, let's say this is 50 pounds, and this is how we measure wind, pounds per square foot. And this is actually very reasonable. 50 pounds per square foot on the what used to be the third floor is very possible. And then down on the first floor, now remember it's open, so you may even have something less. It might be down to 10. Well, what happens here at this interface is that they build part of the building, and then everyone goes on a lunch break or goes on vacation. And when they come back to put on the third story, the people that are supposed to strap the third story to the second story, now they may not have strapped it correctly. They may have strapped it correctly, but it was too weak for the code at the time. They may have strapped it correctly, but corrosion basically created a condition where there were no more fasteners in those areas. But essentially what happens is you lose the capacity of your roof to wall connections, and your third floor. So when you lose this, you've lost the rest of the house. My guess would be, likely they lost probably the sliding glass door wasn't installed well. When that happens, it gets pressure inside the house, and then it's much easier for the roof to for the wind to push upwards into the building. These are all just my guesses, so don't hold me to it. I'm not any kind of collapse expert. I'm just a guy with a PowerPoint presentation. And the standing seam metal roofs, they perform fairly well. The only problem is if they're not strapped in completely, then the home is no more. I worked in standing seam metal roofs when I first started, and they have these metal clips that help hold the roof down. So the roof indeed can then now be strong, but we always wondered, well, what about the roof? What about the rest of the building? The building's 50 years old. What happens if the straps aren't strong enough? So those are issues that come up, and you may question them yourself in a home inspection. The point is that, first of all, we can only improve so much before it's not economically feasible. So we can't go around to every single building and lift it 15 feet in the air because it's too close to the water. We can't go to every building and restrap every single truss, but we can do a better job at the parts that we are protecting and that we have access to when we repair or reconstruct the building, or when the building is sold in a real estate transaction, which is where the home inspection comes into play. If the home inspection report says there are temporary floor jacks under the crawl space. That's all that needs to be said, as the presenter before me said. That's all that needs to be said. Your job is then done. It's their job to figure out how to make that right, or if they want to buy the home and assume the responsibility. And then they can call an engineer like myself if they want, or any of the licensed engineers that are in their community, who can then certify for them or tell them how to fix it. So the point is being able to help them understand we can't make everything perfect, but we can sure get very, very close. And we want to get as close as we can, because even when we do a really good job, sometimes we can fall short. So the point is we want to make sure that we're always on the mark, and we're trying to make sure that our customers understand what they're working with if they're dealing in a hurricane situation. This home, 1997, so it's a little bit newer than the ones we've been looking at. And it's also elevated above the ground. So we have about a 12-foot clearance on the first floor. Again, the water should be able to rush underneath the home, assuming that water doesn't get too high. If you want to notice the right side of this house, you could look at notice the staircase. And they also have sort of a living unit underneath. There's actually some walls in there that are designed to break away. And this is the aftermath. So again, a gable roof condition. The breakaway walls underneath are missing, so the room is gone. And then we've also lost a little bit of this wall. You can tell there's a little bit of a lean, slight tilt there. So it was actually measurable at lateral displacement of about 2 or 3 degrees. And it's questionable if this could be repaired. Probably. I mean, it looks like maybe half of the house is still inhabitable. You still have the roof, but you certainly have lost quite a bit of the structural integrity. This is the same house. If you look east, it's the same structure. So if you keep your eye sort of on that center window. Now, my guess is that center window, again, was probably installed by the same guy that did the third floor on the other house, because that's what happened to it. So the 2 windows on the right managed to stay intact. The third window, either it wasn't necessarily the window even, it looks like it was the entire wall section. We sort of lost a square or a rectangle in the matter of the left side to the right side of the window, about 2 or 3 feet either way. And again, this is all coming from suction. This is being pulled out of the building. This is as wind most likely entered the front of the building from the water side, and then tried to rush out and over the building, and eventually pushed out this wall. So if you look closely, this was actually a bearing wall system. You have a bearing wall condition where the girder that holds the upper floor was relying on this area for its support, for its connection. And as you can see, we've lost support of the girder. That's why that wall is angling. So this connection here, this is a floor to wall connection. Another floor to wall connection is here. These are similar to the roof to wall connections, but it's just to give you an idea of how critical they are and how important those are. So it's really critical that our roof to wall and floor to wall connections remain intact. Simpson Strong Tie, if anyone doesn't have their catalog, you can buy it online. I recommend it. It's a nice read. Part of their catalog has these diagrams, which really help to indicate what is it that we're working with when we're talking about the safety of a structure. It's easy to show all these straps, and they have a million of them, but what does this really break down to? So when you look at a clip such as this is a rafter to top plate connection. So on a wood building, you would have a wood roof on the top, and the wood roof would rest on what's called a top plate, which is the 2x4 or 2x6 wood framing member of the bearing wall. And remember, we sort of have that here. There's the top plate up here, and the framing member is resting on it. So the roof basically transfers its loads into this little clip, and then that clip transfers its load into the framing member, which then travels down the wall. Now, once it travels down the wall, it's got to make its way from the first floor to the floor below. And all that's got to be thought about, detailed. It can't just be 2 nails into the side of the home. Now, in the 50s and 60s, sometimes that was done, or it was done out of necessity. It was just easily done. The codes weren't that strict. But now it's very critical, or it's I would say it's become mandatory that the engineers, the contractors, the home inspectors, if they're involved in any of this work, understand how how to read this chart. What is this chart telling you? It's saying that there's a floor-to-floor tie. There's a steel tie of some kind that's got 8 nails in the top, 8 nails in the bottom. And what it's allowing the structure to do is resist axial loads in both directions. So that if the home is lifting up, or you have competing loads where one side is lifting and one side wants to stay put, this strap helps to maintain that load connection. So not only do you have a roof to wall connection, but you also have a floor to wall connection. And then lastly, you've got the wall itself has to be connected to, whatever it has. So if the wall has any kind of top plate, bottom plate, anything that's used for framing or to make it convenient, then we've also got to get all of those straps together. And finally, it's all got to make its way down to the foundation. Because if it doesn't make its way down to the foundation, as we saw in one of those very first slides, the entire home could then slide off of the foundation, and it might be in one piece, but it's no longer in the properly surveyed location, to put it lightly. Which means, yes.
Oh, go ahead, sorry.
I was just going to say, it would mean that the home is in someone else's home.
I think we have a question here that is relevant to what you were saying about the beach houses. It says, what percentage of the beach homes have rusted for missing hurricane straps?
Say that again. What percent of the beach homes have rusted?
Of the beach houses have rusted for missing hurricane straps.
Well, I would say that probably about 30 to 40% of homes that were older than, let's say 1980, had corroded strap conditions. So due to salt air, due to you can actually see it on the next slide. There's going to be some siding that came off. So when the water is able to get through the siding from a hurricane, let's say 5 years ago, or a tropical storm 5 years ago, yeah, you do end up with corroded straps, and nobody's checking those. So you can end up with conditions where the homes fail. Again, maybe the code was adequate, maybe the installer was adequate, but over time, and age, these straps were not investigated, and then they failed. And these are things that, every year, every code cycle, things are updated. Things are noted that are deficient or that come up that are understood through science, such as the gable end issue. When that was understood, then it went into the code. It was implemented. The new Florida Building Code goes into effect at the end of this year. It's going to be setting some new standards for wind pressures as far as roofing. So you may have some roofing products that don't meet their code anymore, which may come up in the home inspection world. So the codes update, and it's important that we work with it, because if these are, as we were talking about, if they were rusted connections, then there may be a time in the future where homes of a certain age need to have exploration done where some drywall is removed and an inspector needs to verify the strap. It's not at all crazy to think that could happen. In South Florida, we have what's called a 40-year building certification, which means that a professional has to walk through the building after its 40th birthday and make sure it's structurally capable. Homes that get that old need something similar. So these are things that may come down the line through the legislation of home inspectors. So it's good to study these things and know them. The load path, is there any more questions? Were there any more questions, Kenya? All right, hearing none. We're going to take a break, by the way, in about 15 minutes or so. We're talking about the load path and the importance of the load path. And when you look at a building like this, you have a very tall, very slender setup. So they look almost a little too tall and narrow. They're built with a little bit more modern construction. They were built after after Hurricane Andrew. They're built after the codes are starting to be enforced, but still around the time where a lot of interpretation is occurring. So what do you think happens to these? I'll give you one guess. They fall over. In this case, this is a sliding failure. So the home receives so much lateral pressure that it literally slides off the foundation or slides off of its level. Third floor slid off, second floor seems to be, looks like the second floor may have stayed, but we've lost bearing walls in the rear of this building. You can see that there's no more walls here. So another failure coming down to the hurricane strapping. If the hurricane strapping and the load transfer is not just right, we're going to have a problem. So we go to minor issues. What happens if it's something small? I just have a broken window, or I just have one window that doesn't have a product approval. I just have one shutter that I can't prove. You know, if you can prove it, that's a different story. But if it's not a structural item, it's a breach in the building's envelope of protection. And if the building can't resist what it needs to resist, you will see photos similar to what you saw there for that neighborhood at some point in time. There's a percentage in the code. I forget what the percentage is, so don't quote me on it. But it's something like, you know, these buildings are designed so that only 1% in 50 years will collapse. But there's still a number that will not survive the storm. So we need to do everything we can to make sure that number stays intact. Even when we follow the code, there's a possibility that we're going to be overloaded. When you have window and door damage where the windows are shaking back and forth violently for hours on end because of the hurricane forces, you're going to have these creases, or you're going to have sealant fissures that you'll see during a home inspection. And a lot of times, homeowners won't notice these until maybe years later, and it's something to look out for. Now, if they've painted recently, it could be something else. But generally, after a hurricane, you're going to see certain damage types and damage patterns that may be obvious and may be not so obvious. If you look here on this pane of glass, this is an insulated glazing unit, and you can see the failure of the glazing unit because you see condensation inside the pane. So if condensation and water is able to get inside this pane, then you've essentially lost the insulating properties of the window. You've also got a sliding glass door. This is a track from a sliding glass door where so much water and debris and dirt is able to get in and underneath the structure that you've compromised the integrity of the building envelope as well. And then, not to mention, I'm sure if you guys have been inspecting it any amount of time for siding is a known water collector basically, and it likes to destroy buildings that aren't properly protected or properly wrapped. And then you've got also obvious and not so obvious. There's certain items that come across, you know, when you inspect some of these, you think that you look at a crack here on the side, this large fissure that comes from the window being shaken back and forth. But some of the not so obvious issues are, you can see right here, maybe there was some repairs that were made to the glazing system before the hurricane occurred. You've also had some buffeting or movement from the frame itself. And those can happen from the frame of the window system being shifted from its position because of a hurricane cyclical load. If you look at the side of the windows, this would be sort of the top view of a section view of a window. When you have wind pressure pushing back and forth against the window, it tends to buffet that frame, even if it's microscopic, even if it's secured in well. If there's any kind of gap there, you end up with a fatigued fastener, and you end up with damage to the waterproofing systems that are required to keep the envelope intact. Anytime that there's an excessive shim or there's a condition, we'll have a picture of it in a minute, showing where something is not fastened completely properly, or where the hole is too large, or the fastener is stripping out, or the fastener is moving. These are all items that you'll notice on an inspection and can end up fatiguing the building and bringing the building to a structural collapse in some cases. You might even see something of a minor nature in the term of wind-driven rain. With siding, you could lift up siding after a hurricane or even after a thunderstorm, and you've got weakened fastener connections, you have rusted nails, The wrap is deteriorated, and wind-driven rain, you'd be shocked at how it can literally get up and underneath this siding. So don't put too much of your faith in gravity, or in this feels heavy enough, or this looks like it's going to be able to protect. The code is really starting to go more and more towards prescribing how these products are supposed to be installed, what they're supposed to be, what they're supposed to look like, and how they're supposed to be certified. And that's where you guys come in terms of proving that that's out there when the home is released for sale. You have siding and roofing, the same thing. And what's interesting in these is, remember we talked about this corner pressure multiplier. Whenever you're working on the corner of the building, you're going to have excessive damage after a hurricane. So any windows or doors that are on the corners of buildings, downspouts that aren't secure that are on the corners of buildings, if you notice those are prime areas of issues. Those are prime targets for the hurricane, because as the wind tries to navigate around those sharp corners, you get vortices and eddies that end up ripping those portions away. If the roof is sufficiently strapped down, but the structure maybe has some wiggle, has some shrinkage, or it's a framing member that's not connected properly, you might also inspect and notice cracks in beams. You could notice cracks from tops of doorways and headers. Those are areas that are notorious for shifting and moving after a hurricane, as the wind works left to right and up and down on the structure. Panama City was about 10 miles inland of Mexico Beach, maybe 5 miles inland of Mexico Beach. It did better. The buildings were a bit newer. They were commercial buildings, but they also struggled mightily with the connections and making sure that the building had the right roof to wall connection and had the right strapping connections. And when they didn't, you would see something like this, which is what I saw. I saw on Google Maps, I saw what looked like maybe like an old video rental spot and a large one-story wall. We have a parapet wall here, which is going to be putting a wind force against the wall. And then you have your traditional, we can call it an infill wall here, which is going to apply wind force to the infill wall. In between that, you've got a beam that runs across all the way down to the end of the building, and a series of columns. I believe here we've got 2 or 3 columns. Now, when wind applies its pressure, in this case, we lost the parapet. There is no more parapet wall. So the parapet wall has been completely detached from the building. We've lost all of the infill material. And the only thing remaining is essentially the bones of the structure. Luckily, that's still intact. But we've lost all of the building. And the reason is because this wall is a cladding element, and it's notorious that it's forgotten about. It's not inspected. People, even city inspectors might look at it and shrug. So it's important that, we take these seriously, because when you notice the effect of it, it's not a beam necessarily that's going to go. It's going to be a connection. It's going to be some small item that people are not really paying attention to, that receives a high enough force, and when that goes, it ends up in a domino effect that the other pieces are not designed for. This is how it happens. You have the front of the same building. We have a structural column here in the center, structural column in the corner, and the beam running across under the parapet. Again, there's no parapet, so we've lost the top part of the wall. You've also lost everything else. Papa John's, you might be able to get a pizza, because it looks like they got just enough wall remaining. But that's it for that building. And it's on and on like this all down the street of Panama City after Michael. This was across the street. It's hard to tell. This was the Google map on the top, where you have a masonry structure. And the masonry structure stayed intact, as you would imagine, because it's masonry. But what didn't stay intact was the large sail that was attached to it to create this nice looking facade. And you see this a lot in construction nowadays. And this was probably going to be the next thing to go in a big storm, is you're going to have these huge gaping holes as the steel columns, bigger than my hand, pull away with the force of probably about an 18-wheeler, the weight of an 18-wheeler. So that amount of force basically collapses the facade, and they can save the building, but the facade is completely destroyed. The pet supermarket, another issue, same thing. The connections failed. The building essentially had no shear or lateral resistance, and it lurched forward and collapsed. And it was just like this on and on, all down Panama City. The way that this happens is you have wind loading the system. When wind loads the truss or the roof, you have an uplift that occurs, and it occurs in sort of a cyclic manner. So it shakes the structure enough that you can have this sort of microscopic wiggle back and forth rapidly, thousands and thousands of times per minute, over and over and over. And what it does is it fractures the connection, or it could fracture the member, and then the member and the member that is being supported and the supporting member separate. And that's how this damage is occurring. When you look in the code, this is the code that is used for wind pressure analysis. This is a graphic illustrating how to apply the roof overhang load. When you apply that kind of pressure properly and you analyze it under hurricane force, you realize that some members are going to be overstressed that were designed in the 80s. This is a picture from the Keys where the straps stayed, but the actual roof lifted off. So a home inspector, even myself, I would have certified this as a good installation until a hurricane came along and decided that the straps were strong enough, but something was going on with the roof members that they weren't strong enough. So again, it's all about the links in the chain. You've got to have everything rated properly by either the engineering or the code. And even when you have all the straps right, in this case, I think what happened on this one was that there was a large patio extension installed against the truss, and so it created a big sail, and then it ripped off the truss. So the code probably was well enforced, but the extension may not have been, the engineer may not have accounted for that. If you look at what's happening to a truss in a computer model, and you exaggerated the displacements, you would see something like this. You would see the truss lifting on its overhangs on the tail ends. You would see it kind of being loaded and lifted from the wind vertically, and then the hurricane straps would create a lot of stress in the truss, holding down the span and the load from being pulled off of the structure. Because remember, when it pulls off of the structure, we no longer have the same structure. And that's what's so important. So when you fill out that form for your home inspections for what is the roof to wall connection, this is why it's so important, is because if we lose that roof, then the walls are next. So the roof to wall connection is the primary cause of structural failure, the primary cause of death in an impact, a trauma impact from someone that is mortally wounded in a tornado. The roof to wall connection is the exact item that is the weakest link in the chain after we fix things like, it's high enough for the flood, and we have strong enough concrete, and we did our inspections. You could do all of that, but the roof to wall connection, if that goes, you'll no longer have the same building. This is a Home Depot building in Texas. You can see the massive amount of damage. I mean, you're talking about a 25-foot roof. This is collapsed in the background. And you have steel roof trusses that are coming out that you can see pre-engineered or pre-formed steel roof trusses. Those no longer have any connection. The connection is somewhere down here. The trusses are in acceptable condition, but of course the connections failed. So something happened where this wall no longer provided the needed support. And we want to know why. And I'm going to come back to that picture. And I want you to, and you guys are going to notice something about this in a minute when we come back to it. Because for every picture that shows damage, there's something that might make it through. Even for tropical storm winds, this was just down the road from me about a year ago. This is a parapet wall and a facade similar to the one that we just looked at that had the hurricane failure and hurricane damage. They put this system up, and within about 48 hours, we had a tropical storm threat. Winds were no more than maybe 30 miles an hour, and this was the result. So this is probably a $30,000 construction effort gone to waste because all those members are now shifted and moved and displaced because of the hurricane forces. This is another view. That's an expensive mistake to make. Something could have been done here that would have helped this structure to survive, and we'll talk about that in just a minute. Because even with all of the damage that we're talking about, even with everything we see, you still see a news article like this that says that every bungalow survived. This island withstood the exact same forces that those homes withstood in Mexico Beach, except these homes had the capacity and the design to resist those forces. It almost looks, this is a few days after the storm, it almost looks like you could still vacation there. There's a little debris, the windows are intact, rails are intact, roof is in place, nothing is out of order here. So there's obviously, that tells us that there's a way to make it through. There's a way that we can do this to where it's a win for society. We have these homes, the same type of home in another location near Mexico Beach. You notice it's got this spiral sort of spoke wheel, and it's a round shape. It's also elevated above the ground. So there are some ways that that this would do better or would fare better than its stick-built neighbor. You've got the same home here. You have the round conical sort of shape. This is called, they call it a Deltec home. And then you have, this is the neighbor with the traditional stick-framed home. It's from another view, Deltec again and the stick-built neighbor. And many people heard about this home or saw this. This was the Miracle House. This was designed by the architect for 200-mile-per-hour winds, almost as a bet, and turns out it was a good bet because you can actually even see, not only is this home still standing, but there's looks like there's some chairs on the outside there to still enjoy the home. Even with the destruction and utter chaos around it, the home is still intact. So this proves the concept that we can survive, we can work through this, but it requires everyone working in unison to make that happen. What is the secret to these structures? Well, they have a unique round shape. The Deltec homes allow the hurricane force winds to go around the structure. They don't build up on one side. The buildings themselves are very strong. So they're held together with floor trusses. They have sort of this center spoke, and the building is strong because of that layout. And the products are certified and tested. They have storm-tested impact glass. Framing lumber is designed by an engineer. These are things that put you in the success column. Remember that parapet wall we talked about? Hurricanes destroy, but only if we let them. Because they were able to right the parapet wall, they were able to brace it properly, and they were able to actually save the structure. But they should have done that before the storm came, so they got lucky. The same thing with our Home Depot. Remember the collapsed Home Depot building? We have a small pergola type structure. Now, granted, these things are decorative, so they're open, so I'm not saying that, but this guy must feel really lucky. There's a way that even with the destruction behind it, this one in front, this is my certification as an engineer. I designed this small pergola, and it actually did better than the building behind it. So I'm proud to say that it's possible to make it happen. And lastly here, before we take a break, it's all about two things: the hurricane strapping and the uplift load path, which we talked about. So this is vertical uplift strapping and uplift forces that we want to make sure that we're looking at or we're certifying for. And then we're going to talk a little bit after the break about lateral load path, which is what the engineers are working with and the codes is working with, which is how the roof wants to slide off, which is basically transverse to that uplift. So there's some links in the building envelope. We're going to cover this once we get back about how the loads transfer. and we will be back. So we will resume. I've got 2:05, so we'll say how about 2:10? How's that sound?
Sounds great.
Yeah, that sounds good. Um, Troy, if you want to look on the chat, I sent you a message. It was one that was sent to the panelists.
Okay. Okay, so I'm seeing we can give a so we have this is about the shirts, right?
Yeah,
Okay.
and then I'm gonna send another one to you as well.
Okay. So just so everyone knows, there are some quiz questions that are going to come up in the second half. This is just to so you're not falling asleep. And there are some basically what we want you to do is when the question comes up, the first person to give the right answer in the chat box, Miranda will be working to give away House of Horrors shirts. So this is the T-shirt showing off that building that has all of the code violations that was built down here in South Florida. So you get a free T-shirt as a giveaway, and it shows off your support of InterNACHI. And then there's also a special one, which I'll save towards the end. There's a receptacle tester with GFCI. So if you guys pay attention, we will be watching in the chat box. There's about 5 questions. So we're going to come back. I'm going to put this on. Let me edit this real quick. If there's any questions that you all have about hurricanes or anything that you want to get into before we resume, write them in the chat. Otherwise, we'll be back at 2:10. All right. All right, so welcome back, everybody. Hopefully you're still with us. I know this is riveting stuff. I promise you when a hurricane crosses, you will be the best at any quiz questions that your family gives you. Go ahead, if there's a question, Tanya.
So there's two. So the first question, do all Florida homes require hurricane straps?
Very good question. Very, very good question. I'm gonna answer that with a quiz question in about 10 minutes. So if you want to take a stab at that and you get it right, you'll get a free T-shirt.
Perfect. You know, it actually looks like an attendee answered the question. But there is another question. Just let me know when you're ready for it.
Go ahead.
Okay. I see straps for the edge of the structure wall to roof. Is there a longer strap or maybe metal pole toward the center of the roof that you could see in the attic, or is it just strong wood members to handle the wind loading uplift?
I see straps for the end. So he's saying that there's straps on the end of the roof. Is there a longer strap, or is there something that's needed in the center that you would see in the attic, or is the wood just doing all of the work? So that's a really good question. It's basically saying, you know, how does this work? If the wind is pulling up in the middle, how does it make its way over to the side, right? And so the way that works is, back when we were looking at the model of the truss and what it looks like, if the truss is strong enough, and this is really critical because we're going to see a few of truss modifications here in a minute, and you guys I'm sure have seen your share. If the truss is strong enough and it has not been modified incorrectly, then you'll be able to get that load all the way over to the truss strapping. So you're able to, if you have a strong enough member, you don't need anything in the center because the roof is strong enough. Does that make sense? Hope that helped and didn't hurt, but we're going to move on. The buildings themselves. Now we've talked a little bit about the hurricanes. We've talked about modeling. We've talked about the trusses and how they're going to react, or how we think they're going to react. And all of this comes down to code, scientific suggestions, and mathematical requirements. What does that mean for you guys as home inspectors? So what I want to talk about next has to do a little bit more with the application of it. So we've covered what we've covered in terms of how we have damage, but let's talk a little bit about the application of it. And that goes into, before I get to the application, it goes into remembering what we talked about, the links in the chain. So it's no good having everything, on the roof nice and certified if the walls themselves are not properly rated. So in Florida, there are a few requirements, and it's the same in most parts of the rest of the nation, in terms of what needs to have a product approval and what needs to be certified more than just a typical, printout maybe from the manufacturer. So that's what that question is in regards to, in the sense of, how do I know that the strap is okay? Or am I allowed to just accept anyone's answer that the strap is okay? Now, before we get into that, I want to talk about the 4 critical links of the uplift load path, okay? The first link is the wind hitting the roof. It lifts the roof upward, okay? It's going to pull the roof upward. It's going to pull the sheathing upward and attempt to essentially create a vertical force on the entire structure. Well, my PowerPoint is playing games. Now, the attachment of the roof covering to the plywood is the first thing. So we have to make sure that our shingles or whatever is attached to the plywood. The next, we need to make sure the plywood is attached to the trusses. This is where on the home inspector form, you'll oftentimes see what is the nail spacing and size of the nails that attach the plywood to the trusses, because it's link number 1 in resisting a hurricane. Link number 2 is the accumulated load that's happening as those nails do their duty. They hold the plywood down, and the accumulated load of the plywood spreads out over to the link number 2, which is the strap that holds the truss to the wall. Link number 3 is the wall itself. The wall itself needs to be strong enough, rated for the forces involved, and it needs to have a strap down to whatever the wall underneath it is. That wall then has to have its strap down to the foundation, and then link number 4 is finally the foundation. The foundation transfers all of that load down into the ground. Now, this is a wood structure, a wood assembly, but the same applies for masonry. It's just masonry shells and reinforced concrete instead of strapping. So those links show up in the building envelope, and they provide the uplift load path that needs to be resisted and needs to be investigated during anything that's visible, I should say, during a home inspection. Same view, this is a bit zoomed in, so you can see the critical 4 links in the uplift load path. And remember that we not only have uplift, we also have lateral, which is side to side. So the side to side action is resisted similarly, but this is where we start to get into windows, doors, shutters, anything that would resist what we call out of plane load that's occurring at the wall locations. The Florida Administrative Code is under 61G20, and it says that products in the following categories shall be available for approval by the Commission pursuant to this rule for use in the state. So they say in yellow, you must make these available for approval. Panel walls, exterior doors, roofing products, skylights, windows, shutters, structural components, which is pretty vague, so take note, and impact protection systems. Now, they're very specific that they say that this rule applies to approval of products and systems which comprise the building envelope and structural frame. So anything that basically protects the building envelope that is a product that can be pre-manufactured has this extra level that the Florida Administrative Code calls shall be available for approval by the Commission. So if you look at, let's say, if you look at any of these certifications, there's a few ways that they can do it. They can do in Florida, they may have a Florida state approval, they might have a local Miami-Dade notice of acceptance, or they may have some kind of an engineer's letter or an engineer's report. But usually you need to have one of these 3s. And if you're watching from outside of Florida, it's not the Florida product approval system, but the IBC does have a similar system for ratings and straps and things like that. So it's the same idea whether you're in California or Colorado or Florida. It may just be a different system. I just happen to focus on Florida because that's where I live. So option number 1 is the Florida product approval system. Basically, it's a website that you can go on and find the product, find the roof panel, find the hurricane strap, whatever it is that you can get data on, and it'll tell you right there whether it's approved, whether it's been tested, and to what standards it's been tested. You have the same idea in option number 2, which is the Miami-Dade Notice of Acceptance. It's a county-wide product approval system. A lot of municipalities in the islands, the U.S. Virgin Islands, Puerto Rico, the Bahamas, these are places that would use a Miami-Dade NOA. It's basically a government approval that says we've received engineering from, XYZ person. It's about this product from this manufacturer, and we've approved it. And then lastly, you might have, let's say you go on a home inspection and neither of those is available. You might have something in the form of a structural report from an engineer. Now, an engineer can't just wave his hand and say everything is fine. There are certain rules in place. For instance, a hurricane strap must be tested. A window must be tested for impact rating. Certain things can be calculated and certain things must be tested. So when you talk about the requirements that the state puts on us, what they're saying is you have to have some form of contribution to how strong this item is if they are one of these 8 items. Panel walls, exterior doors, shutter components, structural components, sorry. Oh my goodness, apologize, my computer's going backwards. And those components must be approved before they are installed. They must be part of the permit package. So it's something that generally is going to, if they're visible, they will show up in your home inspector report. So if you have shutters that you can see, windows, doors that you can see that have labels, those would be reported to the homeowner as approved if you can find them in these databases. If you see a roof truss that's been modified, that comes more into the engineering option because you're not going to find a manufacturer certification to print out of a roof truss that's been cut. So there are certain elements that you have to really carefully understand the code and understand what is it that the code is intending. Generally speaking, though, windows, doors, and roofing products, 100%, they need to be tested in some kind of an accredited laboratory. The days of those products just being installed because someone built them in their garage is no more, at least in Florida. So if you can't find a label, that may be a problem for your client, something really important. Some good home inspectors might be able to use the state systems to search for the manufacturer and maybe do a reverse search, but you've got to be really good at that, and it takes a little bit more documentation than most homeowners might have. The code essentially allows these documents to be approvable. It says that there are alternative materials, designs, and methods of construction that exist in the world, and that this code is not intended to prevent anything that's alternative. In other words, if an engineer needs to design something like a truss repair, or there needs to be a replacement involved in the construction of something that's not manufactured, the code allows engineers and architects to make basically a report. A research report is what it's called, where supporting data can be provided for. Now, it might have to be a test report, so the engineer might need to make the homeowner go back and get something tested if something shows up as a failure. And all of this is essentially being done so that Chapter 1604.9, which says that counteracting structural actions have to be accounted for. In other words, when we push left, the building has to push right. And when we lift up, the building has to pull down. And when we push down, the building has to press up. When all of those forces are contained and counteracted, then we have what's called a continuous load path, and that allows us to transmit the forces down to somewhere that's safe, so it's not over our clients' heads and it's not over the top of the building. You're ending up with the force getting into the soil below. So here comes the quiz question. Remember, these are the products that are part of the Florida Administrative Code. The question is, which 3 products in this photo require a Florida product approval? Now remember, we talked about the different categories, 8 categories. If you just want to list, first person that can list 3, we can review it later. Let's see who gets this. Let's see if we can. Kenya, you can tell me what they get, but
Yes.
first,
Yeah, go ahead.
okay, so we'll go with 1. 1 would be the sliding door. Hopefully some of you got that. Obviously, a sliding door needs to be certified. Next, a roof panel. We talked about the uplift that would occur on a roof. We need to resist that. And lastly, How about an impact, a roll-up shutter? Now, there's a couple of other items. If you said skylight, you would also be
Yeah.
right.
I have Glenn here was the first one to say skylight, roof, and window.
Bing, ding, ding, ding. Where's my, hold on. I have something for you, Glenn. This is the part of the training where everyone's getting loopy, so you might as well. So we have a gong here. Glenn, well done. Good job. Well done, sir. Moving on. We ready to move on?
Yes.
Okay. The basics of wind pressures. So we went over a lot of these photographs. I want to cover how briefly how wind pressure works. We talked a bit about wind rushing over the building. You know how wind there's wind in the back of the building and over the sides of the building. So the problem is wind does not like sharp corners, and anywhere there is a corner or anywhere there is an increase in the height, you're going to have more pressures, more force, and more of a hurricane impact, a hurricane load. So what that kind of looks like in a graphic form is just the corners of buildings. That's where you want to be cautious, and that's where you want to make sure if you're able to get into the attic in those areas, those are where your straps are most critical. Those are where the uplifts would be highest, and those are where the zones would have higher coefficients. So we want to make sure that those are accounted for. Here's another pop quiz. While inspecting a crawl space, you should probe for decay if the blank is dark in appearance. King joist, floor joist, masonry wall, bearing wall. And you should probe for decay. Remember, you're in a crawl space, so king joist would be out. Masonry wall would be out. You're not going to have decay in a masonry wall. And the bearing wall is not quite enough information, so we would say B, floor joist. Floor joist you would find in a crawl space.
Perfect. So the first person was Carl Christopher.
Way to go, Carl. Very nicely done. Good job. Now remember, the king joist would show up in a vertical. It would be above the crawl space. Another quiz question: identify the definition of the term collar beam. A, nominal 1 or 2 inch thick members connecting opposite roof rafters. They serve to stiffen the roof. B, concrete, either with or without reinforcement or reinforced only for shrinkage or temperature changes. C, a horizontal projection from a wall forming a ledge or supporting the structure above it. And D, a nominal 2 inch thick member, 2x4 cut in between each stud diagonally. And the answer is A, it's a 1 or 2 inch thick member that connects opposite roof rafters. So who did we get there?
We got Charles Walter.
Charles Walter, very nice. Are these? Hopefully, there's different people. So if they win twice, I think you get an extra prize. We're not sure what it is yet. The balloon framing versus platform is a common misconception with some people. We have to understand that balloon framing is essentially the studs running all the way up the wall. It's a low shrinkage, so the building doesn't shrink or settle, but it's a fire risk because the fire can run up the wall and create a chimney effect. And that's something that you all would have seen on your primary exams for licensure. So I wanted to cover that. We also have platform framing, which is the opposite. You have sort of decks or platforms that are being built onto the structure, and the advantage is you don't have a fire risk because it's not a chimney situation. But the disadvantage is that with all these little connections, you're going to have vertical shrinkage. There's a quiz question on that as well, so we'll come back to that. Now, when you're building, usually with a platform building, but it could be either way, you're going to have joists that have to bear and seat on proper structural connections. And those fasteners aren't allowed to have a gap behind them. They're not allowed to rotate. And you're supposed to have enough bearing so that the structure rests upon the proper, let me go back, on the proper support. So if you see here, you can just tell right here there's a end bearing condition that I would say is a problem. It's laser pointer. So you could see how on the end here, we only have about a half an inch of support on the joist hanger. And we're traditionally, you need an inch and a half of that support. So if you're looking up on a floor system or a deck system, one of the common causes of deck failure is this joist slipping or there being a gap. So we want to be cognizant of that, and we want to be able to see that those gaps aren't exceeding what's recommended. If you're looking at a deck joist hanger and you see incomplete installations, you see this all the time where it's designed to receive 10 nails, 4 nails, or so many nails are missing. There's 4 nails missing in this condition, and so therefore you have a reduced capacity of the hanger. You probably come upon this every now and then, where you have some kind of a modified truss that's got some kind of change to it, and the question then becomes, is this allowed? And really, as a home inspector, the best answer is contact a structural engineer for further evaluation if it's something that you can't make a comment on or that is a structural modification. But certainly this is not manufactured. This is not one of those first two where you would have a pre-engineered system. This would go under the third one, where an engineer would possibly need to provide some kind of information for how this would get designed or how it was designed. Here's my favorite one because it keeps me in business. A builder has added an additional load to a wood truss in the form of a water heater. Under what circumstances does the International Residential Code allow this? Never, always, allowed if the load has been verified, or D, none of the above. Let's see who gets this one first. They want to hang a water heater on the truss. The answer would be C. Of course, you can hang it from the truss, but you need to make sure that that's been verified. So a smart homeowner maybe has a letter stapled to that truss if that was a modification that was added later. And if they don't, or if you're questioning it, then you may want to contact an engineer to get that letter. Oh, sorry, who won that one?
The first one was Luis Trebanco. So Luis, just please send us your email. I'll be asking for it in a second in the chat.
Thank you so much. And thank you to InterNACHI for letting me give away things.
Troy, do we have a couple more quiz questions?
Yes.
Okay, how about the next 3? We give the receptacle.
Okay, the receptacle tester?
Yes.
Gotcha. So the joist bearing and seating is what we just covered and how important that is. You can kind of see here how this is cockeyed. You have a rotational issue here. So if you're ever looking up on a decking system, all those joists are supposed to be properly seated, no gaps, proper amount of anchors, et cetera, et cetera. Excuse me. With windows and doors, essentially, hopefully, you're going to have some kind of a product approval information so that all of these configurations that you see, if you have to investigate them, these are approvable within the system. When the windows are manufactured, they have traditionally 3 different types of glass. It's the load resistance of the glass. It's a safety factor of 4. And you can go, you start with annealed glass, and then you end up with tempered glass, and that's how they get stronger. Annealed glass you can kind of think of as your horror movie glass or your Hollywood glass. It breaks into huge shards if it's broken. And then tempered glass is the glass that breaks into very small bits, and it's a much safer condition if it's shattered. So a lot of hurricane products are made out of tempered and laminated glass, and those products have anchor limitations. They've also, those products have anchor limitations that end up with certain spacings that must not be exceeded. So if you have a product approval or you're investigating any of these products, these are items that come into play. When you have a shutter, the product approval information is required to be listed on the shutter. They may be a Miami-Dade NOA. It could be a Texas TDI product evaluation or an International Code Council evaluation. But those test standards state that it's required to have labels properly on the shutter. So if you're looking at an accordion shutter, your label is going to be either at the bottom of the shutter or it'll be centered in the center mate of the shutter. If it's a Bahama shutter, they'll be on the back of the shutter. And if they're, of course, these are the code requirements, but if they're not installed correctly, that's another issue. A rolling shutter, they are generally at the bottom of the shutter as well. The label is installed towards the bottom or up at the hood. And then your panel shutters are traditionally a permanent panel, and they're supposed to be every 3 feet. So the code has a few rules on storm panels, and it's supposed to be one permanent label per panel. So if you find them in the garage, the requirement's supposed to be 1 permanent label per panel. All right, now when you're looking through structural damage, these are the 2 final sections of this presentation. You know, we're talking about structural damage issues, what to look for. You have vertical cracks, horizontal cracks, step cracks. It takes time and expertise to understand the difference between all of them. But the idea is that can you identify the difference between a severe crack and something that is a shrinkage crack? So if you're in the foundation and you're seeing large, greater than 1/4 inch cracks in the foundation walls, those may be severe cracks. Now, if you have a small step crack, we'll cover in a minute what the crack might look like in the left and right directions. That will help you understand if the wall is moving in a certain direction. But the thing about cracks is you don't want to cause so much alarm that your clients are upset that you've inadvertently created an issue that's not there. But you also don't want to be so laissez-faire that you don't give them enough information to understand that some settlement may be occurring. If you're in the attic, you have water damage. You're going to see wood rot. You're going to see damaged ceiling joists. How do you know if the trusses were modified or if those were engineered properly? It really comes from the experience, and it comes from working with your local InterNACHI association and also the forums that InterNACHI provides, so that if you're missing, I think on this photo we have a missing ridge board, it's like you don't even know what to do sometimes when you find these things. So it's important to use your network and use the InterNACHI system to help yourself. This is a photo of some insane hurricane strapping that a client of mine did, and I showed up, and it was like, why would you do this? And he essentially unstrapped his own house so that he could try to restrap it to his patio, and it was just a mess. It was just completely unapprovable. And these are the things that get modified when no one's looking. And it's important that, if you see something like this, if you're in the attic and something's been modified and doesn't look traditional, that it gets called out, because, truss modifications may not have been permitted. They may be approvable, but they may not have been approved at that time. And so it's really important. I love this one, just a little cut. I hear this all the time. Oh, the AC guy just wanted to make a little cut, and then 6 trusses get snapped. And again, it might be fine for today, and today's a nice, beautiful day outside, but it will not be fine when those winds are being applied into the structure, as we saw before. A professionally engineered truss modification, you can tell. It's got different members, it's got beefier reinforcement, there's structural plywood that's used. So this is an example of sort of a tray ceiling. And it's all about resisting those load paths. If we modify our trusses and we can no longer resist the load path correctly, the building can come down. We're going to have a problem. And then lastly, we've got the 2 field reviews. So what is the difference between shrinkage and severe cracks? I will tell you. You have some shrinkage cracks, which you'll find on every single home. You'll find stair steps in the corner. You'll find verticals under the window, horizontal lintel cracks. You're going to find all sorts of cracks. What's important is determining, number 1, if they've been painted recently. Number 2, if those cracks are because of the paint or because of new finish work that's been done. Number 3, if the crack itself has paint in it from that recent paint, it could tell you how old the crack is or the age of the crack. So there's questions that you can ask to help determine what this crack is telling you. So in a stair step, if you look closely on this stair step, you'll notice that the vertical legs of the crack are uniform. So on that picture here, on the yellow highlighted picture, the vertical legs are fairly uniform. There's not a measurable separation there. And then the horizontal legs, you see chipping, you see irregularity, and you see a little bit more of a gap. So what that would tell us is that the building is sliding left to right, or the wall is sliding left to right, and that could mean it's moving horizontally. So it's moving horizontally and it's not moving vertically, which could mean that you have shrinkage cracking, which is different from something where you're vertically moving and we have an issue. So here's a quiz question for the receptacle tester. While inspecting a 1-year-old house, slab on grade, you observe hairline cracks in the concrete floor, but no vertical displacement. This indicates A, insufficient reinforcement, B, unstable subsoil, C, overhydrated concrete, or D, normal plastic shrinkage. Remember, there's no vertical displacement. So it's important to understand that concrete cracks. If it ain't cracked, it ain't concrete, is the old saying. So you're going to see cracks sometimes in a 1-year-old house. You're going to see it on a slab, let's say, if there's no tile or if they just pulled the tile up. But with no vertical displacement, most likely you just have normal shrinkage of the concrete.
Okay, the first person to say B was Scott, but he already won. So let's go to the next person, Carl. He already won as well. So the next one would be Bill Rich.
Bill, all right, Bill, good job. So normal plastic shrinkage on a concrete floor because you may see concrete crack. Now, if you can put your hand in the crack, if you have extreme vertical settlement, this would be a completely different story. And how do we know that a crack is severe? Well, you might define it as exceeding 1/8 of an inch. So if you can fit a penny into the crack, that would be determined severe. If you have wall cracking on the outside that correlates on the inside with drywall cracking, so on the left, you can see the inside of the home with drywall separation, drywall splitting. On the right, the same crack, but on the outside, splitting the stucco, splitting the block. It's an irregular crack. See, this is very different than the stair step that we saw where you just see a little bit of shearing, very little of vertical displacement. In this case, you have an irregular crack, and you also have they're wider at the top than they are at the bottom. So that essentially means, and you can kind of see it in this lower left-hand corner, it essentially means that it's splitting open. The bottom is kind of compressing, and the upper portion of the crack is opening. So, I mean, these are things that are difficult to tell even as a structural engineer, but if you can kind of get an idea, especially if you see interior drywall cracking, then you're certainly more on the severe cracking side of things. This was a project that I did personally. I got called out because of a home inspector, and thankfully I saved the buyers from purchasing this home. There is a little bit of settlement here on the lower part of the house. The home inspector caught it. He also caught this tiny little crack right up here in the middle of the wall. It looks extreme on the picture, but it's hard to tell in real life. And then my finger, I could actually get my hand underneath the foundation, as you see on the bottom of that. And when we went inside, I said, "Can I please pull up the carpet?" They said yes. It was a textbook 45-degree concrete crack that ran right on that corner area. So this is an area that would require some foundation underpinning. It's probably going to cost about $10,000 to the homeowner if they were to buy the house. And it's so obvious. The home inspector did a great job because as soon as he stuck his hand under the foundation, he knew that this is an irregular crack, and I can see the foundation. Everything is giving me the red light here. We have, so on that note, what is the minimum allowed slope of graded soil next to a building's foundation according to the IRC? So we have to slope the soil so that this doesn't happen with our footers, our foundation. The International Residential Code provides for that. It has a requirement: 5 inches for 10 foot, 5 inches for 12 foot, 6 inches for 12 foot, 6 inches for 10 foot. This one's a hard one. So whoever gets this one, even if they already answered, I think they should get the tester. What do you think?
Okay, sounds good.
Okay, so.
Also, we have like 5 minutes left.
Okay, good.
5 minutes left, sorry.
Good, I'm almost done.
Okay, and I have a couple questions for you. Oh, so sorry.
That's all right.
Okay, so the first person was Carl, who had already won the t-shirt, but we're gonna give it to him as well, right?
Way to go, Carl. Carl's a good inspector.
Okay.
You said there was questions. You want to handle those at the very end?
Just really quick, because that one is related. This person is asking, where can I get the gauge you're using to measure the cracks?
You can buy them on Amazon. Just look on crack, crack gauge or crack card, any of those. You can buy them on any kind of supply online. So they're real. You can actually buy a kit that's got, I think it's about $30. It'll have a couple of different cards on it. There's a couple of different ways that you can handle that. Also, on Amazon, you can buy crack monitoring kits. So if you don't want to take any responsibility, or you just want to tell them, let them worry about it, you can also recommend these little kits. They're about $50. They put a cross eye against the crack, and then if anything moves over time, it'll show up. So it's sort of a do-it-yourself. Let them handle it. Now, this is the last section of slides. I'm just going to go through these pretty quickly because this is just more. I wanted you all to see what it looks like when a house does look like it's a severe settlement issue. It's actually been fixed and it's still settling. This is a home that had 2 additions, and one in the front, one in the back. It actually had some retrofit foundation pilings that had been installed after it had been built because it had started settling into the ground. And you can see them. This is what they look like on the outside of the home, if you've ever come upon them. And this is what a true settlement issue looks like. So you'll know on a home, you see bulging of the columns, okay? You're gonna see 1/8 inch and 1/4 inch cracks in the column. You'll see a crack on the outside, that's a little, a little 1/8 inch crack, and then walk inside and the crack is almost a 1/2 inch or 3/8 of an inch on the drywall. You'll see cracks running on the beams from one part of the building to the next part of the building, up over the ceiling, down the beams, down the next side of the beam, down the other side of the rear column. So you'll be able to tell if you have a true settlement issue. Once it starts to really kick off, this is the map of cracking we saw in this home. And we were able to read some of the reports from the engineers on why they did what they did. And essentially what they recommended, which didn't necessarily help in this case, is they recommended helical piers. Helical piers are screwed into the ground to help support the foundation. The problem with helical piers is they compete with pin piles, which are a little bit more traditional, and some would say a bit more stronger, because pin piles or push piers go directly into the bedrock, whereas the helical piers screw into the soil. So just to let you know, there's a few different types of ways that these are fixed. Essentially, you'll have a contractor that could come in, he underpins the foundation, jacks it back into place, puts everything back nice and square, and the engineer gives a shoring and sign-off plan. So, all this is part of how it's done in the field. If you see settlement, these are some of the more traditional issues you'll come upon as the home inspector if you're not finding straps or hurricane damage. And we have our final 3-question quiz. So I have 3 questions left. Is that all right?
Yeah, let's, we have 2 more GFCI receptacle testers and 1 more shirt.
Okay, cool. Let's do the shirt first. So for the key shirt, we have which of the below types of wood framing has greater risk for fire and flame spread? Balloon framing, remember, which is where you go all the way up to the roof with your wood studs. Platform framing, which is where it's interrupted. Post and beam construction, or ICF construction. And the answer to that is going to be balloon framing. And the reason is because you have this sort of chimney effect as the wall is uninterrupted all the way up to the roof. And who got that one?
Okay, that was John O'Neill.
John O'Neill. All right, John. Thank you, John, for participating. I appreciate it. Next, we've got question number 2. EIFS is a siding material that is used in commercial buildings only. Looks like stucco, but lacks a wire mesh. C, can be installed on top of a modified bitumen membrane. Or D, can be installed on top of a masonry surface. EIFS. EIFS stands for Extruded Insulated Finish System. And the answer for that is going to be B. Looks like stucco, lacks a wire mesh. The winner is?
1 second here, I'm going through them.
Oh, this is for the circuit tester, by the way.
Okay, it is B, correct?
Yes.
It's Richard Schumann.
Way to go, Richard. Very nice. And we have our final question for the receptacle. The normal minimum run for a residential stair tread is 10 inches. 10 inches, minimum for a residential stair tread. And who won that one? That's going to be C.
It is gonna be Jonathan D'Angelo.
Jonathan. Way to go. Way to go, everyone. I really appreciate everyone and their participation today. I know these are topics sometimes that can seem like they're overwhelming, or there's a lot more information than maybe meets the eye at first. But to conclude what we talked about, this is the eye wall that we looked at. This was this 500 feet of Mother Nature's force that our buildings, our community had to resist when the moment came. So we want to make sure that when the moment comes, we're there, we're ready, we've done our work, we've done our training, and our homes and our society is safe. Thank you very much for all your attention.